All right. So let's wait a little more. Let's wait until 7:05 to see if we have any more students joining in. And then yeah, we can begin on the sessions. So my name again is Kai. I work for Nova Systemic. I go to school at George Mason University, computer engineering. Today we have our co-host, Nate Sebastian.
Hello.
If you have any questions, feel free to unmute yourself and talk to me just like last time. Or again, you can go ahead and type it inside the chat. I'm going to check the chat periodically whenever I can, but Nate is going to check it period. So if I cannot answer the questions, Nate will. All right. So let's get started with the class for today. I'm going to share my screen with the PowerPoint. There you go. Can everybody see my PowerPoint just fine?
Yep, I see it.
All right, sounds good. All right, so welcome to VEXCode Virtual Robots, session number 3. That should say 3, not 2. I edit the PowerPoint. All right, so let's talk about our robot, a couple of review for our robot. So last sessions we went over the down eye, which is a camera module that allow you to track colors and lighting. And then we also went over the electromagnet, which is the motor that let you interact with the objects, more specifically the disc in the last game that we played. A question, does everybody have vr.vex.com turned on? Because if you don't, I highly recommend you do it now before we get into our sessions. And in session number 1, let's get back to it. Session number 1, we also talk about the pen, the wheel. We talk about the bumper sensors for the right side and the left side. We also talk about the built-in gyro and location sensor. So we went over pretty much all the sensors that VEX Virtual Robot can offer for us. And today we're going to do a little more advanced coding per se, and not just, turn right and turn left. We're going to do it variables. We're going to do it a couple of while loops, a couple of forever loops, or repeated loops. All right, so let's talk about a pretty important thing is efficiency. Because I mentioned, what was it? I mentioned my block last class and why my block was important. So my block is important because it allows you to do your code in the most efficient way possible. So why is coding efficiency matters and what is it? So let's read from the slide. Coding efficiency is a term used to depict a reliability, speed, and programming method that you use in developing your code for an application. In this sense, we are using it to solve a maze, right? It is directly linked with algorithmic efficiency, the speed of runtime, the speed of executing your software. What matters the most here is the performance. So high performance matter a lot. If your code can solve a task in the least amount of steps possible, then it would also take less space. Less storage unit. Less hardware space in megabytes. One of the most important example of this, or most popular example of this, is sorting algorithms. Right? If you have a more efficient sorting algorithms, you can sort numbers or sort colors and stuff like that in, the least amount of time, which is the fastest. So that matters a lot, efficiency. So let's talk about the objectives for today. Let's analyze it together. On the right side of the screen, you can see a grid with numbers from 1 to 100. So what is our objectives for today? Each block is 200 by 200 millimeters. So this block right here, if everyone can see my mouse, can anybody confirm that? Nate, can you confirm that for me that you can see my mouse?
Yeah, I can see your mouse.
Perfect. So each block is 200 by 200. What does that mean? It means that if you want to move from 1 to 2, for example, you have to go forward for 200 millimeters, right? If you want to go from 1 to 3, if you do the math, 200 plus 200, 600 millimeters, so on and so forth, right? You want to go to 4, it's going to be 800, 5 is going to be 1,000, right? So the objectives for today, the main goal for today is to hit every number with the least amount of lines in your code. Again, we just talk about efficiency. So what does that mean? That means you're going to go from here, take this path or whatever, as long as your pen is going to draw a line that hits every single number in this grid. So that's our first objective. Our second objective is to drive to a specific number. So I'm going to create a code. We are going to create a code together that say, if I enter in the number 45, our robot just going to move directly to number 45, so on and so forth, right? If I enter in number 56, for example, our robot is going to drive there and then go straight to 56. So that is our second objective. The first objective, pretty easy. We already solved the maze the last time, and we already solved the disk the last session as well, which is pretty easy. Everybody know how to drive the robot at this point, I hope. If not, then I highly recommend go over the PowerPoint that I sent you guys. So the first objective is pretty easy. What I'm going to focus on for today is the second objective. Everybody should be able to enter in the number and drive to that specific number. So what is the importance of driving that number? Driving your robot to a specific spot in the maze that you want it to go. It is important because it allows you to customize your code. So say, instead of writing 100 lines of code or 100 tasks in your code to reach each specific number, you are going to write only one code for all the numbers on the grid. And today I'm going to show you that. So first of all, let's talk about my variables. I went over all the other functions in the last two sessions. So these are going to be the last two functions that I'm going to teach you guys. The first thing is my variables. So normally when you enter in a variables, say you want to go forward for 200 millimeters, you enter in 200, right? And if you want to go forward for 300, you enter 300, stuff like that. So why does my variables matters in this sense? Let's say you have two steps. First step is to move forward 100 millimeters. And then the second step is to go forward, say 500 millimeters, right? So if you use my variables, it allows you to set the first variables. So the first variables would be to move forward for 100, right? So you're going to set your variables to 100. So that's the first variables. And then also you can change it. Change that variables by 1 or 2 or 3. That means you're doing the math, right? You can set your custom variables or custom numbers or custom amount of distance that you want to go. So that is one of the more advanced stuff that we're going to learn today, is to set your variables with math and not typing it in. And the second thing I'm going to talk about today is make a block. So we learned how to make a block last class, but we did not deal with any numbers or Boolean or any variables or labels. Last class, we only dealt with my block, right? Custom functions, very easy custom functions. Well, this class, I'm going to teach you how to add an input to it. And I'm just going to show you how to add your own my variables into make a block. So we're going to, combine a lot of stuff today. We're going to combine stuff from the first sessions and as well as the second sessions into this. So let's talk about an example of using my block with number. Using a number variable in my block helps with, you can differentiate between different variables you put in, right? It's a more optimal way of using custom functions. For example, this, I know there's a function to drive forward for how long or how far you want to go. But in this sense, instead of putting the drive forward for a custom amount of number into the code, I can put that into my block with a specific number, and I can edit that number. So let's test that out, right? I'm going to turn on my VEX VR now, and I'm going to stop sharing the PowerPoint first. And I'm going to share VEX VR. Nate, can you confirm that you can see my VEX VR on the screen?
Yes, I can see VEXVR.
All right, perfect. So this is how you're gonna do my block with number in VEX VR. Again, click and drag, very simple. So you're going to say block name. For me, I'm going to name it as drive for. By the way, everybody should do this at the same time as well. So drive for, and I'm going to input a number. So I'm just gonna click on that, and the number, I'm going to name it distance. Press OK. Go all the way up to drive forward. So normally, if I want to do this, I can just do that, right? 100. And my robot is going to move up or go forward for 100. If I type in 200, it's going to move up for 200, right? Pretty simple. But now I'm going to plug it in here. I'm going to pull this distance to that. Go down here, go to my block, where you can just click there, go to my block, pull that out, plug it in here, and now you can customize that instead. So 200, 400, whatever, right? So let's test out 400, see what happens. I'm going to press start, and it's going forward for 400. Pretty simple, right? So that is the most basic example of using my block with a number variable in it. I know you can just do that, right? Like, I'm fully aware you can just do that, but this is the more optimal way, especially when you have many lines of code in your my block. All right, let's go back to the PowerPoint. Share screen, swing to. All right, so that is how you do my block with number. Let's go on to the next step. So here is why my block with custom variables matters. Let's look at the left side and the right side. The left side is when you use one number variables inside your my block. Say I want to drive forward and then I want to turn, right? For how many degree that is, turn left or turn right. So if you want to turn right, it's 90 degree. You want to turn left, 180, right? Simple. So instead of doing this, which mean I have two variables, two my block functions. So drive forward, distance, just like I just show you, and then turn for degree, just like I just show you. Instead of having two my block and 3 lines of code in my main code, I can turn it to one my block and only 1 line of code in my code, right? It's, again, the whole sake of efficiency. That's my main goal for today, is to talk to you guys about efficiency, how to make your code the most efficient as possible. So instead of doing this on the left side, you can do this with 2 number variables, right? So you can drive for distance, you can turn for degree, or you can even have the third distance in there if you want to. Both of them do the exact same task. Drive forward for 100, turn for 90, and then drive forward for another 100. So both of them do the exact same task, but this one on the right side is the most efficient way to do it. So let's test it out, right? Let's try out my block with 2 numbers. VEXCode VR. Alrighty. So let's do it in the more traditional way, right? You go to playground, change this thing to number grid map, because that map is what we're focusing on for today. Go to number grid map. All right. Let's go to number 2. Turn for degree. And I'm going to move forward for 200 millimeters. And that should take me to number 2, right? So just test that out. Turn right, go forward. Hit number 2, right? What if I want to go forward more? I just enter the number. Easy, simple enough, right? 400. Now that should take me to number 3. All right, cool. So that's the more traditional way to solve this maze using just only the drivetrain, right? But now we're going to introduce my block into it. So how do you do that? Make a block, click on make a block. Block name, I'm going to name it drive forward and turn. All right, drive forward and turn. And I'm going to have 2 variables. The first variable is going to be distance for the drive forward. And the second number is going to be degree for the turn degree, right? Click on that. So now instead of driving forward and turn, I'm going to say turn 4 degree and drive forward. But instead of using the number that you enter here normally, I'm just going to click this, drag the degree into that block right there, and then drag the distance to this block right here. So instead of this, I'm going to go to my block, pull this out. So I'm going to drive forward for, remember the first number is distance, and the second number is degree, right? So the first number, I want to go exactly 400. So I'm going to type in 400. And the second number is the degree of turn. I'm going to type in 90. I'm going to delete these 2. So let's test it out. See if it still do the exact same function that we intended to do. All right, exactly the same function, just with custom variables. So that is the one advantage of it, right? So let's go to our first objective. I'm going to stop sharing the screen. I'm going to share the PowerPoint. Let's talk about the challenges for today. The first challenge is to clear the grid with normal codes, which mean using the drivetrain to just drive and bump into things and, repeat that over and over again. The second objective is to clear the maze using my block, just like what I just showed you. And then the last objective is to go to a specific number. So here's the code for solving the maze normally using the forever loop function. Let's try that out. I'm going to have the code on one screen, half of my screen, and then VEX VR on the other half to make it a little easier. So that's half. VEX VR on the other half. Perfect. Okay. Can you guys see my screen just fine?
Yeah, I can see it.
All right, so half and half, right? Perfect.
Yeah.
Great. So let's try that code out over here. I'm going to delete all of this. So we have a forever loop and a couple of drivetrain. So let's look at the map for a second. So first, if you want to go this path, right, you're going to turn right. go forward. And then you're going to stop right there. You're going to turn left, go forward, turn left again, go forward, and then turn right, right? And then basically just repeat the exact same thing over and over and over again. Cool, let's do that. So first thing is to turn right for 90 degrees, no big deal. And we're going to drive forward. Again, each grid is 200 millimeters. So if I want to go from 1 to 10, I have to go 9 grid, which is 1,800. And then I'm going to turn right again. Actually, I'm going to turn left this time. Turn left. Drive forward for 200, which is 1 grid. So now we go from 10 to the 11th and 20th. And then I'm going to turn left for 90 degrees. And then I'm going to drive forward, just like I just did. 1,800. Turn right for 90. Can everybody hear my audio just fine? Okay, great. Denise, I think it's just you.
Yeah, I can hear you just fine.
Okay. So you're going to turn right, and then you're going to go forward for 200. So let's test that out. Right? Same playground, same number grid map. Forward. And remember, we have the forever loop over here. So it's going to go over this forever, right? I'm going to leave that right here so you can see the session of the code. You can't really see it. Okay, cool. Basically, the concept works, right? Our code works. We are able to solve that maze using traditional way, so the drivetrain way, right? We can hit every single number just like this. I'm not going to let it run. You guys can get the concept already. I'm going to move on to the next step, right? And again, this PowerPoint will be sent to you later on. So no worries if you cannot follow the code or stuff like that. I will send you the PowerPoint. All right, cool. So we get the concept. Great. Let's move on to the next step. Can everybody still see my PowerPoint just fine? I would assume.
Yeah, I can see it.
Great. All right, so let's go to the more important or harder stuff that we're focusing on today is to drive to a specific number, right? So let's go to VEX VR and explain how we're going to do this. So if you look at the number grid map, again, 1 to 100. Let's say if I want to go to number 11, right? What do? I drive forward for 200, right? That would take me from number 1 to number 11. So number 0, 1 to number 1, 1, right? So I'm going to have it as X and Y. So the first number, or X1 and X2, however you want to imagine the math, the first number is going to be 1. And then the second number is going to be 1. I'm only focusing on the first number right now. So say if I want to go to 2, I go 200, which is the size of one grid map, times 2, right? And that should drive me 400 meters up, or millimeters up. So let's look at the math. One grid is 200 millimeters. To move forward one space, you go forward 200. Makes sense, right? To go forward 2 spaces, you go 400. So the math would be X times 200 millimeters, right? So let's test this out. Oops. So let's test that out. Here's the code on that side. Going to delete all that. Again, my block, make a block, define. I'm going to name it drive to. I'm going to have my first number and my second number. So if I have 99, my first number is 9, my second number is 9. If I have 57, my first number is 5, my second number is 7. Makes sense, right? So first and second. Let's worry about the first number first, right? So if I want to go from, oops, what happened? Oh, there. If I want to go from 1 to 21, I just explained the math is x times 200, right? So that I'm going to drive forward. This time I'm going to use the math functions over here. So operators is the math function. I'm going to pull this time out, replace that, put the first number in there. Oops. Put the first number in there, have this as 200, and I'm going to put the whole thing in there. Okay, so now if I'm starting, so I start at 0 and 1, so first block. Say I want to go to 31, right? Let's see what happens. Let's see if our robot can actually drive the 31 or not. Drive exactly the 31, right? So let's test it out again. Let's see if it can hit 61 or not, right? Press start. So enter in number 6, press start, drive all the way to 61. Cool. So that's one column. Let's take care of rows. So that's how we'd be able to move in the Y directions or the column directions or vertically, however you want to call it. Let's worry about the horizontal. So if I want to go to number 2 or 3, 4, 5, 6, 7, 8, 9, 10, how do I do that, right? So let's go back to the PowerPoint and I will show you exactly how you'll be able to do that. So let's talk about the math real fast. So to move to number 2, you go forward 200 millimeters. To go to number 3, you go 200 plus another 200 is 400. Number 4 would be 600. Number 8 would be 800. I mean, number 5 would be 800. And number 6 would be 1000, right? Makes sense. So that is how we do it in the more traditional way and with the drivetrain. But now we're using math. So I actually did the math for you guys already, so you don't have to worry about this. I actually did the math right here. I did it like an hour before the session started. So the math is going to be x times 100 plus 100 times x minus 2. So that is the math for it. But we're going to replace this spot because it just make our life a lot harder having 2 x's in there and then more math in there, because every time you enter a math function, you put 1 green space into it. I don't want to have like 5 green space in one function. So the math is going to be x times 100 plus 100 times x minus 2. But I'm going to replace this whole thing with a y function. So the x function is going to be your second number, and the y function is going to be your variable. And remember, the advantage of using my variable is that it can change throughout your code. So first of all, let's take care of that y variable first. I'm going to set that y variable to 0. So it starts at 0. And then I'm going to put this math in there for y. So the math is 100 times x, which is our second number, minus 2, right? So that's the whole function. So at first, your y is going to be this, and then we're going to replace that y with this functions that we just created. Does that make sense? Does anybody have any questions or any confusion that they want to ask? You are more than welcome to unmute yourself. Everybody get that concept? Okay, Michael said yes. Okay, I'm just gonna assume everybody get that concept. So first step, I just explain it, replacing the y with the functions, yada, 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 or replace the function with a y, and this term is interchangeable. Doesn't really matter for us. So the second step is to write this in, this whole code. This is the drive forward function. This is how far we want to drive. So I'm going to replace that. So drive forward, remember the second is our x. So second number times 100 plus the y functions, which is this one, right, in there, in millimeters. So let's test that out. Again, I'm only testing the second number. I'm not going to worry about the first number right now. Just going to ignore that. Okay. Let's go to my variable, make your own variable. I'm just going to name it my variable. Right. I already named it right here, so I'm just going to cancel that. But so my variable, pull that out. First of all, we got to set it as 0, right? And then we're going to set a function to it. So change it by, and then to do the math, you go here. So first we're going to pull out the minus. So the second number, minus 2, according to the math we just did, times 100. So times 100. And that is the function for our y. All right. But when you look at the map, if you want to go in the row directions, you got to turn right first, right? First, you got to turn right and then you go forward. So let's have a turn right in there. Turn right for 90 degree. And then the second function or the main function that we have is going to be, go back to operator. I'm going to pull out a plus and a time. So second variable, second number times 100 plus my variable. So it's in variables right here, my variable. And I'm going to plug that into the distance. So instead of distance, that's what we're going to use. Does everybody understand what I just did? Okay, Michael said yes. Great. Kiara said yes. Perfect. Nicholas said yes. Okay, cool. Everybody understand it. Great. So let's test it out. See what happened, right? Let's try number 2. See what happens. See if our code actually turned to number 2 or not. That's what we're worried about. 2. Cool. So 2 works. Let's try a random number. Let's try 6. Right? Start it. Okay, great. Drive to 6. What about 10? If you want to enter 10, how are you going to enter it? Because, you know, we have only tried it with 1 or 2 or 3, like one variable. Let's try 10. Let's just enter 10 in, see what happens, right? Start. Let's see if it's going to drive to 10 or not. Okay, great. That works. So if it works for the first roll, theoretically, if we combine the column session that we just did, which is this one, is for the first number, and the row, which is the second number, if we combine those two that we just did, it should be able to work for every single numbers in here, correct? Cool. Hey Nate, was there anybody waiting in the waiting room that you were did you get in?
I didn't see anyone waiting.
Okay. All right, so let's share the screen again. Everybody see my screen just fine? Oops.
Yep, I see it.
Something is wrong with my webcam. Let me just reset that. So there you go. That's better. All right, great. So if we combine those two together, there is no reason why it should not work, right? Just basically no reason why it shouldn't work. We just did row, we just did column, and we test them out, and both of them works. Okay, so let's combine it, see what happens. Here is the code for driving to a specific number. Basically, we just did this portion. This, that, and that. We just did that. Now, all we got to do is just put the move forward with the first number in, right? So let's do that. Drivetrain, move forward, put it right there. For, instead of a specific number, I'm going to go to math with the times. My first number times 200. That's what I said, right? First number times 200. So let's check the code, see if it's right or not. So let's drive to my variables, go forward, turn right, go forward. Cool. All right, let's test it out. Let's test it out. So the first number we have, let's just try 13, right? Just a random number. See if it works or not. Go forward and turn. Stop. There you go. That's 13. Let's try, I don't know, a random number, maybe 47. 47. Click and start. Okay. It drove directly to 47. But now let's try out 100. Because remember, if you guys remember the second number, so here's the disadvantage of this code, right? Remember when we did this row right here, we did 1 to 10. We have to enter the second number as 10, right? And if we want to go to row number 9, we enter the first number as 9. So in theory, if I enter 100, it is not going to work. I have to enter 910, right? So let's do that. Let's type in 9 and 10 to see if it's going to drive to 100 or not. Okay? Load playground, start, drive all the way to 9, and then I'm going to drive all the way to 10. Okay, so that's 100. But we didn't enter 100. We did not enter 100. We entered 910, right? What would happen if I enter 100? 100. Can you guys take a guess what would happen if I entered this number in? You guys are more than welcome to unmute yourself.
It keeps going. It just runs into the wall.
Okay, so that's the first guess. If I enter 100, it's going to enter in the wall this way. Does anybody have any other guess?
It's not gonna move.
It's not going to move. That's an interesting one. Why not?
Because there's no number with 1 and then 0, 0 after it. It's normally 0, 1.
That's a very good observation. So if I enter in 100, Nicholas said is not going to move. So let's test it out. What happened there? It moved forward, it turned, but then somehow it went backwards. Why is it going backwards? So if I enter the second number as 00, it moved backwards. Why is that? Does anybody have any idea of why if I enter in 00 for the second number, it moves backward? No? Okay. So here's the reason why it moves backwards. If I enter in 0 for the second number, 0 minus 2 is -2 times 100 is -100, is -200. -200 plus 0 when you type 910, it kept going after 100. I think there's something wrong with your code. You can look at the code example over here to see if you copy everything exactly right or not. I think that's the only explanations of why it did not work. If you click and drag everything as how I just did it, it should not go after 100 if you enter in 910. Okay, so 100 is the only issues that we have, right? Or is it? What if I enter in 80? Is it going to go to 80? It did not go to 80. Why is that? Why is it not going to 80? If I enter in 80, why is it going to 81 and then get stuck there? Can anybody just guess why that just happened? So I enter in 80, right? I enter in 80, which is 80, and then it go to 81, and then it tried to go to this direction. What is in this direction? Nicholas, you have an idea?
Because you start at 1, and then to go to 2, you only need to move 200. So to go to 80, it tries to move to move to 80, but then it goes to 81 instead and moves back.
Okay. That's a very interesting observation. So here is the reason why it went to 81 and then go to the left instead of going to the right like we taught it to. If you look at this, 81, and then directly to the right is 82, then 83, 84, 85, 86. That is if we went to the right direction, which is the positive directions. What if we goes left, right? 85, go left, one space, 84, go left, 83, go left, 82, 81. If we go left one more, theoretically, if we can go left, what should be right here?
80.
80, right? So this is 80. So that explains our robot behavior. That explains why it went to 80 and then tried to go to the left side, because it thinks that 80 is right here and not right there. Does that make sense? Does that make sense for everyone? The robot went to 81 and then turned left because it thinks that 80 is right here instead of right there. That makes sense, right? Okay, cool. So that's our only issue with the whole drive to number that we have. Everything works from 1 to 99. So this space right here works, except for 10, 20, 30, 40, 50, 60, 70, 80, and 100. So except for these numbers right here, this whole column does not work. Why? Because our robot thinks that instead of this column being on the far right side, it is on the far left side. Does that make sense? Does that make sense for everyone? Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This whole column is not going to work because our robot thinks that this column is on the left side and not the right side. But then again, why is that? Why does our robot think that this whole column is on the left side? Is there any explanation for it? Is there any explanation of why our robot think 100 is right there and 90 and 80s and all that stuff is over here?
Because maybe it doesn't recognize the 10, the 20, 30, 40, 50, 60, 70, 80, 90, 100 on the right side. And maybe it thinks that all of them are on the left side because it would most likely be in front of the 11.
Okay. Is there any other possible explanation for our robot behavior? Any other ideas that you guys might have? Where do we start? We start at 1. Why is that? Why do we start at 1? And why does starting at 1 mess with our robot?
Maybe because you start at 1, not 0. So
There you go.
places to 0.
Yep. It's because we start at 1 and not 0. Theoretically, if we start at 0, where would 0 be? It would be right here, right? Theoretically, if we start at 0, then 0 would be right there. Exactly. Left side. Thank you, Kiara. If we start at 0, 0 should be right there. And then what's right above 0? What's this number right here? 10. Okay. And then 20 and 30 and 40, 50, 60, 70, 80, 90. If 90 is right there, then where's 100? If 90 is right here, where is 100? $100 should be right on top. Exactly. 100 should be right on top of 90. So that is why we cannot access this whole column, because our robot thinks that this column is shifted to the left side. And the reason to that is because we start at 1 and not 0. Does everybody understand that? Right? Like with the 80, like with the 80 example that I just did. If I want to go to 80, I should go here, right? But it goes to 81 and then it tried to turn left. So that's where 80 is. Cool. So that is one disadvantage of my code. My code can only drive from 1 to 99. So this is the whole space that my code can go to. My code cannot reach these numbers. It can, but you got to type it very weird. So say if I want to go to 70, I have to type in 6 and 10, right? So let's try that. If I want to go to 70, I type 6, 10. And yeah, it's going to go to 70, right? So it's going to drive to 6, and then it's going to go to 10, which is 70, right? Same thing with the concept of 100 that we just did. If I want to drive to 100, I have to go to 9, and then I have to go to 10. Cool? Everybody understand that? Okay, so the reason why my code did not work is because numbers doesn't work like that. The reason why my code didn't work is because we enter in 2 numbers for a grid that has 3 numbers, right? So if I want to go to 1, in this example, I only have 2 numbers. If I want to go to 1, I type in 0 and 1, right? If I want to go to 66, I type in 6 and 6. If I want to go to 32, I type in 3 and 2, right? But if I want to go to 100, what do I type? Because in that example, that would be 3 numbers, right? It would be 1, 0, and then another 0, and not just 2, right? If I want to go to, say, 800 or 821, I have to type in 8, 2, and 1. But we only allow our robot to type in 2 numbers. So the first and second numbers only. That's why it did not work with that whole column, because we only allows it to have 2 numbers. But it works. It can go to every single number on the grid. It works. And that is going to be your homework. Your homework is going to be not homework. It's more like, hey, if you have time, you want to explore it, you can go ahead and do it yourself. Obviously, I'm not going to check it. You can send your code to me via email, and then I can, give you advices and stuff like that. But this is for entertainment. This is for your own, entertainment. So it works. If you want to go to 70, you just have to type 6 and 10 instead of 7 and 0. But that is our code limitation. It's because we divide it by column and row. We divide it by the first number and the second number. So the first number in this sense is 2. The second number is 4. It's because we divide it by the first number and the second number. That is our disadvantage. We did not account for 100 in our code. Again, that's got to be on, your own time if you want to do it. Figure out a way to type 9 and 0, and it's going to go to 90, right? Instead of trying to go left. Okay, so that's what you're going to do in your own time. All right, we're done with this example. But let's just do something for fun. Let's say I want to go to 87. Let's see if it still go to 87 or not. Okay. Drive to 8. And then it's going to go to 7. So 87. Why not, right? To go to 100, you're supposed to type in 9, 10, not 99. So to type in 9 for the first number and 10 for the second number. That's how you go into 100. Same thing with 50. 50 would be 410, and 30 would be 210. When you did 99, it went to 100. Let's test that out. I'm intrigued. If I type in 99, let's see if it's going to go to 100 or not, or it's going to go to 99. I highly doubt that it would go to 100, but you never know. That's 9. No, I typed in 99, it went to 99. So our code works from 1 to 99 and not these round numbers. So 10, 20, 30, 40. Okay, cool. All right, let's go on to the next slide. Actually, I'm not going to close it. Can everybody see my PowerPoint just fine?
Yep, I can see it.
All right, yeah, that's it.